look, I think that, and because I have the microphone, you're going to think for a few moments, that I think we're at a fascinating moment in global food systems, right? And that's because we've got this Venn diagram of climate change, which is really starting to impact all sectors, but also you have this rapidly growing population and also middle class appetite growth. Most people want to eat like the West, unfortunately, and layered on top of that, the third circle is the fact that for the first time in history, we have deep technology that can make fundamental changes to the food that we eat, okay? And this Venn diagram is happening in a context of a younger generation that is comfortable with technology. Not only comfortable with technology, but if you've got kids, you know that they are comforted by technology. And so what does this mean about the future of our global food systems? What does this mean about the intersection between natural and artificial, synthetic and green and sustainable? And so today, I want to tell you about some of the cool stuff that we're doing at Nourish, but I also want to leave you with this question about how do these things interact? What's this nexus between natural and artificial, and how will it change in the future? At the moment, we've got this rather crude debate going between carnivores and vegans, right? But I suspect that the future will be much more sensible and nuanced than this. So our first two products in the field of specialty fats are a meat fat and a dairy fat. So the meat fat is Tasty Lux and the dairy fat is Creamy Lux. And the way that we have done this is by going and trying to identify what are the actual meat fats and the actual dairy fats that make a difference to the types of foods that we eat. And so the first thing I want to do is address why we're bothering to do this in the first place, because we have meat and we have dairy. And so really it comes down to a question of scalability, okay? So whilst I'm not advocating for the removal of animal agriculture, I love a good steak, it does not scale with population growth. So think about this statistic. Livestock occupies 3/4 of global agricultural land, but produces less than 1/5 of our food. Okay, so that might work today, but as the middle class appetite shifts, becomes more Western, grows in India and China, as the population around the planet grows, this figure does not scale. And it leads to questions being asked by some of the biggest food companies in the world. They ask, we make 3 billion cheese slices with the milk that we've got now. We want to make 4 billion. How do we do it? Because they're at this cute but rather alarming concept that they think of as peak milk, where herd sizes are starting to reduce as climate impact begins to bite. And we need to make sure that the inputs that go into our foods in the future are climate resilient and can also scale with population. And so our contribution to making this sort of statistic possible, or answering this sort of question, is that we try and identify what are the growth limiting ingredients. So if you look at a slice of cheese, a lot of it is pretty boring, and you can actually find it in a lot of places when you look down at the molecular level. But some of it is really growth limiting. Some of it cannot be replaced at the moment without squeezing something out of a cow. And so our role is to figure out how to do that, how to make more renewable sources of these types of ingredients. So I'll give you an example of how we did it with meat, and then how we are doing it with dairy as well. So here, this is uncooked meat on the left, and we deliberately start with uncooked meat because we're not after a flavour additive that we add in after the process is done. We're after the actual raw ingredient that we can then cook up in the normal way. And so we did what you can think of as a molecular dissection of the fats that are present in these meats. And what we found is that most of them are actually quite boring. They're a reflection of what the animal eats, right? They're very plant-like. But there is a small proportion of them which are really different, which are really quite animal-like and unusual. And these ones are the ones that we focused in on. And we went and we looked in the soils in Australia, and we found fungal strains which are capable naturally of growing this type or building this type of animal meat fat. And we then grow it up in bioreactors and squeeze the oil out, and then you cook it. And it's cheating, really, because you start with an authentic ingredient, you start with an authentic fat, which you then cook up in a normal, authentic manner, and you end up with an authentic taste, because it is the actual legit molecule, okay? So this here is a novel food. Is it really novel, though? It's the authentic molecule. It's the authentic ingredient from a fungus that, lives in our food naturally. So is it really novel? In the minds of our kids, I don't know. This is a case for dairy, and so on the left you can see here this structure. This is present in milk, which is unhomogenized, so straight from the cow. And what you see is the big yellow circle is the fat. This is milk fat, a triglyceride core. And that's what, when you say you have a full-fat ice cream, that's what the fat is. But naturally, what surrounds it is this quite intricate structure of a tri-membrane layer, a tri-layer, built of phospholipids. On the right-hand side, you see how we currently address plant-based milk fats, and this is just by lobbing in a little bit of plant oil, vegetable oil. Very boring. And so this sort of structure on the right can definitely be improved in terms of its dairiness. And so what we have done in the middle, it's a little hard to make out, but you can see we've got a blob of vegetable oil in the centre, very cheap, very scalable. So I'm not knocking plant production, they're obscenely efficient. But surrounding it is a tri-layer membrane that we have engineered at Nourish. And this is now a high-tech, dairy-like coating that goes around that central molecule, that central triglyceride core, and at a very low volume, very low cost implication basis, adds a dairy-like taste, mouthfeel, creaminess to vegetable oil. And so, again, is this a natural product? Okay, I mean, it's not. We've built it, but it clearly emulates what is happening in nature. And this I find fascinating, because this is how we think about the food design challenge going forward. We're at this point where we are effectively co-designing new ingredients based on natural principles, where we look at food, we look at ingredients and try to get a really deep understanding of how they work in nature. So what is it that makes something creamy? How does it taste good? How does it turn into a lovely roast steak? And we then use that inspiration to build our engineering solutions, to meet these challenges by building the right thing. And then we harness the new technology that we have created to give a really natural fit to our food. And so the question that I want to loop back around to and leave you with as you go to your morning tea is really, where is this nexus between deep tech, nature, and sustainability? Because as you can see with some of these examples, it's not really a straightforward question, that you can have natural, artificial, and the boundaries are somewhat blurred. So thank you very much for your attention. Enjoy your morning tea.